This is fractions day 2, and we're going to talk about equivalent fractions. Starting with yesterday, we basically defined what a fraction is and how it's part of a whole, and we're going to continue with that discussion and add to it a little bit. Okay, now, if we take this whole, okay, so if we take this whole rectangle, right, what I have to notice is all 4 of these rectangles are the same size, right? But I could take this rectangle and cut it into any number of equivalent pieces I want. I can cut it in 2 pieces, right? Like the second one here. I can cut it into 4 pieces. I can cut it into 6 pieces. Okay? But what happens here, right, is if I cut it in 2 pieces, I get a half and a half. If I cut it in 4 pieces, I get a fourth, a fourth, a fourth, and a fourth. If I cut it into 6 pieces, each piece represents a sixth of the whole. Okay? But what if I look at this, if I take this fourth here and this fourth here, aren't these 2 pieces taking up the same amount of the whole as this half is? Right? Then if I take it a step further, right, aren't these 3/6 altogether gonna equate to basically a half, right? So what we're gonna do today is we're gonna talk about equivalent fractions, such as if I look here, that shaded region is a half, right? And here, this shaded region is 1/4 plus 1/4, right? And we're going to say that that's equivalent to 2/4, right? Because isn't that what that is? 2/4. And then this here, you'll have 1/6, you have another 1/6, you have another 1/6, which gives you 3/6. And what we call these, if I look, 1/2, 2/4, and 3/6 are what we call equivalent fractions, right? These are fractions that have different numerators and denominators, but all represent the same value, right? It's almost like going to the grocery store, and if the person at your cash register said you owe me half a dollar, right? It's no different if she told you you owe her 2/4 of a dollar or 3/6 of a dollar. They are all equivalent. So what equivalent fractions are fractions with different numerators and denominators but have the same value. Okay, and that's something that's important to know. And another way we can look at it is fractions. Anytime we see a fraction, fractions are just division problems. So if we took this and we did 1 divided by 2, you would get 0.5. If you were to take this and do 2 divided by 4, you would get 0.5. If you did 3 divided by 6, right, you would get 0.5. We're not really going to go in depth with that, but we will use it later on. So let's take a look and try to make this even easier to understand. So right now it says use the fraction strips to help you find the equivalent fractions. Put the correct fraction in the box and fill in the answers below. If I look here, this rectangle was broken up into 2 boxes, and each box is the same size, which means this represents 1/2 of the top rectangle. If I look down here, right, this bottom rectangle was broken into 4 equal parts, right? So this represents 1/4, this represents 1/4, 1/4, and 1/4. Well, how many of these fourths does it take to equate to this half? Well, I need this one, and I need this one. So how many fourths? 2/4. Okay? So basically we're saying 1/2 is equal to 2/4. Now 1/3, okay? So this top rectangle, okay, this top rectangle is broken up into 3 equal boxes, right? The bottom one is broken up into, look at this, 6 equal boxes. So each box down below represents a sixth of the rectangle. So this would be a 6, this would be a 6, this would be a 6, 6, and 6. Now what you have to understand is, right, the sixth, right, is a smaller portion of the rectangle. Okay, so how many sixths does it take to make a third? Right, if I combine these two sixths, right, if I look, I get that rectangle as a third. This, right, 2/6 would equal that 1/3, right? If you look now, if you take the top rectangle, you notice that box there is the same size as 2 of the 6 put together. So what I want you to do is pause the video, and I want you to try the next one on your own. Okay, so looking at it, right, we have 1/5. 1/5 is equal to how many tenths? If you look, this top rectangle, is broken up into 5 equal boxes, whereas the bottom one was broken up into 10 boxes. So, how many of the tenths does it take to make a fifth? Well, if I look here, here's a fifth. And how many of these do I have to put together to equal a fifth? I have to put 2 together. So I have 1/10, 1/10. So it would take 2/10 to make a fifth. Okay? Now, to talk about the sizes, right, a little bit here. If I had a pizza, if I were to cut it into 5 slices, right, 1/5 of that pizza, right, would be a slice. A slice would be 1/5 of the pizza. If I took the same pizza and I broke it up into 10 slices, one slice would be 1/10 of the pizza, right? Think about it. What slice is going to be bigger? The 1/5 of a pizza or the 1/10 of a pizza, right? This would be the bigger piece, right? And how many pieces of the 10th would it take to make one of the bigger pieces? It would take 2/10. Okay, I don't know if that helps understand it a little more, but you know, understanding these makes a big difference down the road. So next one, draw your own diagram to prove that 2/3 is equal to 6/9. Now we're going to try our best here, to do this. But what we're going to do is 2/3, right, means the denominator tells us how many pieces we have to break the whole up into. So we have to break this up into 3 equal pieces, right? And then if I look, I can shade in. This is 1/3. This would be 2/3. Okay? So now, what we want to do here is break this next one up into 9 equal pieces. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, if I look at this, if I go ahead and shade in, I'm going to shade in 6/9 of this. So there's 1/6, 2, 3, 4, 5, 6. Now, my math didn't really work out because I didn't divide them equally as much. But technically, right, this yellow shaded region, right, should come out to be equal to this yellow region. But when I divided my boxes, I probably didn't do a good job of doing it equally. But it should. Alright, so 2/6 is equal to 6/9. Do me a favor, pause the video and go ahead here, right? For this example, right, 2/10 means I'm going to shade in 2 of these boxes. So I broke it up into 10 equal boxes, right? Here I broke it up into 5 equal boxes. So now I'm going to shade in 2 of the 10, and now I'm going to shade in 1 of the 5, right? So if I look at this closely, what you should see is 2/10 is equal to 1/5. Okay? So now when we look down below, this here I like to think of as like a ruler in a way, right? It's broken up into, you have your one rectangle here. This whole rectangle represents one hole. Now what they did is they kept breaking this down. So you have this represents a half, this represents a half, right? And it takes these 2 halves to make that yellow hole. Then they said, let's take that hole and break it up into thirds. Okay? Then they even broke it up into fourths, fifths, sixths, eighths, and tenths. So what I like about this, what it shows, is how many quarters make a half. So if I look here, the half goes from here all the way to here. So if I follow this down, right, how many of these fourths make up the same rectangle that represents a half? It would take 2 fourths to make a half, or 2 quarters. Okay, so now I'm going to erase all of this right now, and up here, because I want you to see how this works. So the next one says, how many sixths make a third? So if I look here, a third goes from there to there. Now, if I look here, there's the same length. So how many of these sixths make up a third? Okay, and the answer is 2 sixths make up a third. So how many eighths, right? So 1/8. How many eighths make up 3 fourths? So if I look, here's 1/4, here's 2 fourths, here's 3 fourths. If I follow this line down here, it meets here. So these eighths help make up 3 fourths. So how many eighths do we have here? We have 1/8, 2/8, 3/8, 4/8, 5/8, 6/8. So it takes 6/8 to make 3 fourths. So what we're basically saying is 6/8 and 3 fourths are equivalent. Pause the video and try the next two on your own. So how many sixths make a half? Well, if we take a half here, stops here. We look at the 6, right? Stops there, right? So it would take 1, 2, 3 sixths to make 1/2. Okay? And then the last one. How many tenths, right, does it take to make a fifth? Well, here's a fifth here, right? So to go the same length, it would take 2 tenths. 2 tenths to make a fifth. Okay? So to bring this all together, right, to write equivalent fractions. So say you are basically going to multiply or divide the numerator by the same number. Okay, so if I have A over B, if I multiply the numerator by C, I'm going to multiply the denominator by C, and that would give me AC over BC. And this right, would create an equivalent fraction to AB. I could also take AB and divide it by C, and that would give me A over C over B over C. Okay, it's a little harder to understand. We'll make sense of it in a minute here. But the reason I can get away with this is because anything divided by itself is what? 1. Well, when I multiply by 1, does it change the value? No. What's 6 times 1? What's 7 times 1? What's 8 times 1? Right? You get the same number, essentially. So you're not changing the value when you multiply by 1. So what this is saying is, to write an equivalent fraction of 1/2 with another fraction that has a denominator of 4, what do I have to do to 2 to get 4? I would multiply by 2, which means to write the equivalent fraction, I'm going to multiply the numerator by 2 to get 2/4. Here, what do I multiply the denominator by? Multiplied by 5. What do I multiply the numerator by? 5. So that would give me 5/10. That is equivalent. So here, 1/2 is equal to 3 what? Right? I have to find the denominator by. But what do I have to multiply 1 by to get 3? Multiply it by 3, multiply the denominator by 3, and I get 3 over 6. Right? Number 4, 2/3 is equal to how many 9s? Well, here's the thing. What do I have to multiply 3 by to get 9? 3. Multiply the numerator by 3. 2 times 3 gives me 6 9s. Okay? But the next one, do I really want to multiply 12 by to get 12 by something to get 4? No. What could I do? I'm going to divide that by 3. Because 12 divided by 3 is 4. I'm going to go ahead and take 6 and divide it by 3 and get 2. So 6 over 12 is equal to 2 over 4. So when it comes to 10 over 14, right? 10 over 14 equals 5 over what? So here, to go 10/14 is equal to 5 what? Well, to go from 10 to 5, I would divide by 2, which means I'm going to divide 14 by 2 to get 5 over 7. So what happens is 1/2 is equivalent to 2/4, 1/2 is equivalent to 5/10, 1/2 is also equivalent to 3/6, and so on. So try the 3 you try problems below, and then come back and check your answers. So for the first one, we're going to multiply denominator by 3 to get 15, which means we multiply the numerator by 3 to get 9. 20 divided by what would give me 4? So I'm going from bigger to smaller, so divide it by 5. Divide the numerator by 5, and you get 3 over 4. Up here, what do we have to do to 4 to get 12? Multiply by 3. What do I have to do to 7 then? Multiply by 3 to get 12 over 21. This is a very important concept down the road, so being able to do this is critical. So now, if we just wanted to write, say, 2 equivalent fractions for 1/3, this becomes very important when we add or subtract. All I'm going to do is take 1/3, and I'm going to choose any number, right? There's multiple correct answers here. I'm going to take the numerator and denominator and multiply by the same number, right? Say 4 over 4. So 1 times 4 would be 4, right? 3 times 4 is 12. So that's one equivalent to fraction. Then I could also take 1/3, right? And multiply it by, say, I'm just going to make it difficult, multiply by 10 over 10. That would give me 10 over 30. So you could basically say 1/3 is equivalent to 4/12, which is equivalent to 10 over 30. These are all the same value. Now, if I write 2 equivalent fractions for 4/7, right? Again, I can multiply by, say, 2 over 2, give me 8 over 14. Or I could take 4/7 and multiply it by, say, say 5 over 5. It doesn't matter. 4 times 5 is 20. 7 times 5 is 35. So we could say 4/7 is equal to 8 over 14, which is also equal to 20 over 35. Now write two equivalent fractions for 12 over 16. Now this way you could do two things. Say I wanted to multiply by 2 over 2. I would get 24 over 32. So you could say 12 over 16 is equivalent to 24 over 32, but say I also went the other way. I know 12 and 4 or 16 are divisible by 4, so if I divide both the numerator and denominator by 4, it would give me 3 over 4. So that would also, all three of these fractions would end up being equivalent. So do the u-tries, and again, there's multiple answers, so you might get different answers. So come back and check to see if you get any of the same. Right? So we have 1/5 is equal to, you could have 2 over 10, you could have 3 over 15, you could have 4 over 20, you could have 5 over 25. Right? You could have many other different ones. Now 60 over 80, right? I would probably go the division route. So divide numerator and divide denominator by 10. It would give you 6 over 8. Divide them by, say, 2. It would give you 6 divided by 2 is 3. 8 divided by 2 is 4. You could also multiply numerator and denominators, but it's not always the easiest choice. I apologize for this lesson being so long. I will try and make the future ones shorter. So go ahead and attempt the homework, which is following the notes. And if you have any questions, let me know. Make sure you upload your homework assignment also.